Hello everyone, welcome to our YouTube channel. This is our first video and today me, Samyami Sangrola and my teammate Jessica Ariel, we are going to present a detailed explanations of the logistic distribution. What it is, why it is important, its formulas, properties and some real world applications. So let's continue, and what we will cover today. We'll be covering definitions, PDF and CDF, mean variance, shape and graph, comparison with normal distributions and applications. Probability distributions are extremely important in statistics because they help us model uncertainty. We already know common distribution like normal distribution, binomial distribution and exponential distribution. Today, we will focus on a distribution that looks similar to normal distribution but behaves differently in the tails, which is called the logistic distribution. You may be wondering what is logistic distribution. Don't worry, we got you. Logistic distribution is a continuous probability distribution. It is very similar to the normal distribution because it is also symmetric and bell-shaped. But the main difference is that logistic distributions has heavier tails, meaning it gives slightly higher probability to extreme values compared to the normal distribution. It is used widely in statistics and machine learning, especially in the logistic regression, because its CDF naturally maps any value into a probability between 0 and 1. Let's move on to why do we need it. We need logistic distribution when we are working with probabilities that must always stay between 0 and 1. This is especially used for the situation with only two possible outcomes, like yes or no, success or failure, or pass and fail. Another reason we use logistic distribution is because its cumulative distributions function has simple mathematical form, which makes calculation easier. It also gives a smooth as-shaped curve which helps us model gradual growth and smooth probability changes. Because of all these reasons, logistic distribution is the foundations of logistic regression, which is widely used in statistics and machine learning. Now let's look at the mathematical definitions of the logistic distribution. The probability density function or PDF tells us how the probability is distributed over different values of x. This formula may look complicated, but we do not need to memorize it. We just need to understand what each part represents. Here, mu is the location parameter. It decides the center of distribution and is also the mean value. The parameter S is the scale parameter. It controls how spread out or how steep the curve is. A large value of S makes the curve wider, while a smaller value makes it steeper. The PDF is defined for all the real values of x, from minus infinity to plus infinity. The resulting curve is symmetric about mu and has a bell-shaped form. In summary, the PDF defines how probability is distributed. Mu controls the center, S controls the spread, and the curve is the symmetric and bell-shaped. Now let's move on to the important formulas. Firstly is cumulative distribution function. Think of it as like it tells us what is the probability that a value is less than or equal to x. So instead of asking what is the chance of exactly this value, we ask what is the chance of getting the value or anything smaller. That's why it is called cumulative. We keep adding probabilities as we move to the right. Now let's look on to the formula here. Now let's see the important properties. The output is always been 0 and 1. 0 means impossible, 1 means certain. The graph looks like an S-shaped, called sigmoid curve. Why S-shaped? Because very small x equals to probability near 0. Middle x, probability increases fast. Very large x, probability near 1. So it slowly rises, then steep, then flattens. Why this is useful? The CDF is used in logistic regression, and the logistic regressions predicts things like pass or fail, spam or not spam, yes or no. So that's why CDF is important formula. Now let's talk about the properties of the logistic distribution. Don't worry, it's actually very easy to understand. Think of logistic distribution like a bell-shaped curve, similar to the normal distribution, but with a small difference. First property, center values. you will notice something interesting. Mean equals to median equals to mode equals to mu. This means mean equals to average, median equals to middle value, mode equals to most frequent value. All three are the same and located at the center. So the curve is perfectly balanced. If mu equals to 0, the curve is centered at 0. If the mu equals to 5, the whole curve shifts to 5. Simple shift left or right. Now let's have a look at variance. Variance tells us how spread out the data is. Big variance, wider curve. Small variance, narrower curve. Here S controls the speed, so large S equals to more spread, smaller S equals to tighter curve. Now let's have the look on standard deviation. Standard deviation is just the square root of variance. It also measures spread. Again, bigger S equals to more spread, smaller S equals to less spread. Now let's talk about symmetry. The logistic distribution is symmetric about mu. This means left side equals to right side, just like a mirror. So the probabilities are balanced on both sides of the center. Heavier tails, important difference. This is where the logistic is different from normal distribution. It has heavier tails. What does this mean? It means extreme values are slightly more likely, more outliers compared to the normal distribution. So the curve falls more slowly at the ends. Now let's compare logistic distribution and normal distribution. They look very similar at first, but there are some important differences. Similarly, first, both are symmetric bell-shaped. This means the left side and the right side are the mirror images. Most values are near the center, fewer values are at the extremes. So visually, both curves look like a hill or a bell. Key difference: tails. The logistic distribution has heavier tails. We have already explained that in the previous part. So let's go to the second difference. It is CDF formula. The logistic CDF has simple formula, very easy to compute. But normal CDF has no simple formula, usually needs tables or software. That's why logistic is mathematically easier. Key difference: uses. Because logistic is simple and it gives probabilities between 0 and 1, it is preferred in logistic regressions. Logistic regressions use this to predict yes or no, pass or fail, spam or not, 0 and 1. Moving on, let's compare the normal distribution and logistic distribution using this graph. In this figure, the solid line represents the normal distribution and the dotted line represents the logistic distributions. You can see the both curves are symmetric and bell-shaped, meaning most values are concentrated around the center, which is x equals to 0. But the key difference is in the tails. If you look at the far left and the far right sides of the graph, the logistic curve stays slightly higher than the normal curve. This means the logistic distribution has heavier tails. So it gives a higher probability of extreme values compared to the normal distribution. So, in short, both look similar in the middle, but the logistic distribution allows more chances of values far away from the mean. Now, let's discuss the application. Logistic regression. It is used when output is binary like yes or no, pass or fail, disease or non-disease. Growth modeling. Logistic distribution and S-curve model growth that increase rapidly that then slows down. Medicine. Dose response relationships often follow as patterns. Business. Predicting whether a customer will purchase or not. So, to conclude, logistic distribution is a continuous probability distribution. PDF is bell-shaped and symmetric. Its CDF is S-curved and very useful for probability modeling. It is heavily used in machine learning and logistic regressions. Thank you so much for watching our YouTube video. We hope this video helped you understand the logistic distribution very clearly. Thank you.